Welcome to the video lecture series on formal languages and automata theory. In today's video lecture, we will be learning about converting a context-free grammar to Greibach normal form. So this is a specific grammar where we have multiple rules here with appropriate terminals and non-terminals. This has to be converted to a Greibach normal form. The first step, when there is more than one capital letter is accommodated in a non-terminal. Now how to classify that, whether it is a non-terminal or a part of the non-terminal? Now see here, S tends to NP. Now obviously S is called as a non-terminal since it is written in capital letter, and NP. Now see whether NP is having any productions here. So NP is having a production, so NP whole, this NP, N and P together is called as one non-terminal. And next we have VP, and this VP is also having a production here, so this is also called as a non-terminal. Now coming to this, in the next production we have DET. DET is having a production here, so DET is called as a non-terminal. Why? Because you have two small case letters in DET. E and T are small case letters. Since it is having small case letters, we cannot classify that as a terminal. Since it's part of a non-terminal, since it's actually generating a production, that DET is considered to be a non-terminal here. And N is having a production here. N is having a production, so N is also called as a non-terminal. And appropriately VP has been already classified, V and N, and N and P. So V is having another production, so V is also called as a non-terminal. The rest of the things is called as terminals now. Now how to classify this? So first we will try to name this now. So first, starting from the starting symbol, S is called as a first non-terminal. We name it as S as A1. The second is actually NP, so NP is actually named as A2, and the third one is called as VP, so VP is actually named as A3. Now coming to the next production, NP has been already named as A2, we will leave it. Moving on the right, we have DET, so DET will be named as A4, and N is actually a new non-terminal. Now we will name this N as A5. 5. Now coming to the next one, N has been already named. Now coming to the third production, VP. VP is already given a name called as A3. Now moving to the right, we have V. V is a new non-terminal, so V will be named as A6. We will be named as A6. Now coming to the next one, NP. NP is already given a name because it is A2 now. That's it. Okay. So we have altogether 6 non-terminals here, and the rest of the things are called as terminals. Now we will substitute this in the appropriate production. When we substitute this, that means all this A1s, A values has to be substituted in this one. But before substituting this, what you have to take care of this, whether this is actually a simplified context-free grammar or not. Now when you check it out, a context-free grammar should not have null productions or an unreachable symbol, or it should not have an unit production also. Okay, and when you just closely observe this production here, we can see that the second production, that is NP tends to N, is having a unit production. Now third production also, VP tends to V, this is also having a unit production. So the rest of the things are not actually coming under, is not violating the rule. So in this case we have to just take this unit productions out. So how to take this unit production? So first, the first step is, in this methodology we will try to eliminate all the unit productions. So how to eliminate the unit production here? So eliminate unit production. Eliminate unit production. So we will try to eliminate the unit production. So when we try to eliminate the unit production, so we will rewrite the production as it is. So S tends to NP and VP. No change in it. Now here NP tends to DET and N. And now the next is called as a unit production. That means I have to take this N out. So N is called as a unit production now. So we have to see what is the replacement for this N. N can be replaced by dog and cat here. So we will write here n can be replaced by dog and it can be also replaced by cat. Now coming to the third one, VP tends to, now VNP, and now this V is again a unit production, so we will see what is the replacement for this V. Now V has a replacement called as runs and eats now, so we will replace V by runs and eats. Now that's all. We have got rid of unit production, so we will rewrite the productions as it is. DET can be written as the and A, which has two terminals now. Now the fourth one is N can be replaced as dog and cat. N can be replaced as dog and cat, and finally V can be replaced as runs and eats. Okay. Now we will slowly proceed into this order. Now how to replace this now? Now we have gotten rid of this unit production. At this moment we have to substitute this corresponding A values to the respective non-terminals here. So when we substitute this corresponding A values to the respective non-terminals, let us see how it actually goes. Now here S can be replaced as A1. So A1 tends to, NP has to be replaced as A2 and VP has to be replaced as A3. Now coming to the second one, NP is A2, NP is A2 and DET can be named as A4, then N has to be renamed as A5. Now we have one other productions also, so we will write dog and cat because these are terminals. So terminals have nothing to do with the A values here. Now when we go for VP, third production, VP can be replaced by A2. So VP can be replaced by A3, and V can be replaced by A6. So A3, A6, and NP can be replaced as A2. So A2 bar. Now we have only terminals now, runs and eats. Now coming to the fourth production, DET can be named as, coming to the fourth production, DET can be named as A4. So DET is named as A4 and A4 consists of only two productions, the and A. Now the fifth production, N can be replaced by A5 and A5 consists of two terminals called as dog and cat. And the last one, V can be replaced by A6, so it has runs and eats now. Okay. So now we have actually replaced those all A values here. Now the first thing what you have to see here is whether it is actually in a specific form or not. Okay. So what is a specific form? So we have a specific form called as A tends to AJ alpha. That means in this case when I is less than J, now this kind of grammar is always accepted. Now this A1 is called as AI, AJ is called as A2. Now I is actually less than J, so this is accepted. Now when you come to the second rule, A2 and here it is A4, so here 2 is less than 4, so it is accepted. When we are coming here, A3 and A6, so 3 is less than 6, it is accepted. The rest of the things is actually terminal, so it's already in the form now. Now what we have to do is we have to bring this to a Greibach normal form. Now what is Greibach normal form? The Greibach normal form is actually accepting only two forms here. One is actually we have a terminal, on the right side we have a non-terminal on the left side, right side we have only one terminal, or otherwise we have a non-terminal on the left side. It should start with the terminal and it can be followed by any number of non-terminals. So these are the two forms now. Now we will just check this rule here. When we take up A2, you see whether A2 is having any replacement here. A2 cannot be replaced by any terminals here. So but A2 can be replaced by A4. So A2 has a protection here, A4, A5, dog and cat. So what you have to do is we will substitute. So substitute A2 in A1. So when we substitute A2 in A1, so what will happen here is we will rewrite the protection. A1 tends to, so A2 can be replaced by A4, A5, and already A3 is here, isn't it? So this A3 stands in the same position. Now bar. Now A2 has one more protection. What is one more protection? It is A2 can also be replaced by dog. That means if I replace this dog in this place of A2, now this will become dog A3. Now coming to the next one. A2 also have one more protection called as cat. So A2 can be replaced by cat. So we will get cat A3. So cat A3. Okay, now we will rewrite all the protections as it is. So A2 tends to A4, A5, and dog and cat. Now A3 can be replaced as A6, A2. Now runs and eats. So every time you rewrite the protection again, whenever you make a transformation, rewrite every protection here so that you cannot miss any protection. So the and then A. Now A5 can be dog and cat, and A6 is runs and eats. Okay. Now till now we have performed it. I will go for one more page here. So when we come for page number 1, in page number 1 we have these issues here. What is the issue now? Now this has to be converted. This grammar has to get converted here. So when we take this grammar, A1 tends to A4, A5, it's okay now. But when we take A2 tends to A4, this is also okay. Now A3 has A6 now. Oh, what you have to do is, now terminal, non-terminal, a terminal should be followed by set of non-terminals as far as this protection is concerned. Now when we take up this each protection, A1, you have a non-terminal, so we have to see what is the replacement for A4, whether this A4 has any terminals now, and similarly whether this A6 have any terminals now. So we will try to make it out. Now first we will substitute this in A1 now. So substitute this A4 in A1. So when we substitute A4 in A1, so substitute, so we'll just change this color so that we can just make a differentiation now. So now change this. Okay. Now we will substitute this now. So substitute A4 in A1. Okay. And similarly, when you take up the second protection also, we have the first element as A4. So A4 can also be replaced here. So substitute A4 in A1 and A2. So when you substitute it, we will rewrite the protection. So A1 tends to, A4 can be replaced as the A5 and A3. It also has one more protection. A4 can be replaced by A here. It can also be replaced by A. So we will just substitute this A in this A4 now. When you substitute this A in A4, so what will happen? A, A5, then A3. Now when we go here, now this A1 has already other protections also, which is actually starting with the terminal. So no issues with this. So we will write it dog A3, and then it is cat A3. So no issues with this. Coming to the second production, we will go to A2 production. A2 we will replace this A4 by the and A. So when you replace it, what will happen? So the A5. Now second one we will replace by A now. So again A5. Coming to the next one, so we have A2 is having two more terminals now. It is called as dog and cat, so we will write as it is. So dog and cat. So now we will rewrite the remaining production. So A3 tends to A6, A2, then runs, then we have eats now. Okay. The last one is A4. Fourth rule is A4. A4 the, then A, then A5. A5 is dog and cat. And the last one A6 is runs and eats. Okay. Now, when you closely observe this A1, all the productions are in Greibach normal form. It is actually starting with the terminal, or it actually having only one terminal on the right side. So the first two A1 and A2 productions is done now. When we go for A3, still we have to convert that into a Greibach normal form. So what we will do now? Now we will try to do this, replace this A6 now. Replace this A6 with some kind of mechanism now. So now when we just closely observe this A6, so when we closely observe this A6, A6 can be replaced by a terminal called as runs and eats. So we will replace this A6, so substitute A6 in production, which is the production is called as A3 now, in A3. In A3. When you substitute it, what will happen? Now this we will rewrite as usual, rewrite all the productions. A1 tends to the A5, A3, then A tends to A5, A3, now dog, A3, then cat, A3. So nothing wrong with this production called as A1. Now we will rewrite A2. A2 is having the A5, then small a, A5, then dog or cat. Now the point of contention is actually the third production called as A3. That means we have to replace this A6 by the respective terminals. We have two terminals called as runs and eats. So when you replace it, A3 tends to runs A2 bar. Okay, and we have one more production called as eats now. So eats A2 bar. Now the last one here, which is already A3 is having a runs and eats now. So we will rewrite runs and eats because these are all terminals. So nothing to do with the replacement now. Now we'll go for A4. So A4 tends to the A, then A5 tends to dog and cat. A6 tends to runs and eats. Okay. Now when we closely observe this, every component in this grammar comes under the category of Greibach normal form. So either it will be in form 1 or it will be in form 2. So that's about converting into a Greibach normal form. Thanks for watching a video. Have a good day.